Good morning, ladies of calculus. Welcome to room 15, where learning never ends. Even when sometimes we're not in the mood to learn so much, but we are continuing to work on related rates. And at the beginning of class yesterday, we had our first related rates problem, which was a ladder type problem. And I've given you some minutes to work on this problem here. Is there anybody who at this point has come up with some kind of an answer for this problem? Karina, have you come up with an answer? Okay. Well, can you tell me what you got for your answer on this, Karina? She got, so it's feet per second, right? So Karina got dy dt, because it's how fast top, dy dt equals -7/12 feet per second. Is that right? Is that right, Karina? Okay, anybody else get that for an answer? No? You haven't got there quite yet? Okay. Do you need to have a little more time on this? Now, one thing that does give me some, gives me some indication, what tells me that maybe there's some hope of that being a right answer? Because the base of the ladder is being pulled away, so the top of the ladder is going to have to be going down, right? So we know that's a negative number, so that's a good sign. So I want you to go take a couple more minutes, see if you can verify her, or either verify or contradict her answer. Let's say that, or maybe try to work backwards from it and see how she got it. Can you do that? All right. Anyone else yet?
Turn back to put it in the calculator.
We're going to put in the calculator. To me, the only thing that on this problem that is a calculator is a calculator situation. Possibly is that the dimensions of that triangle. But we had a similar type of triangle on yesterday, which would be if you have a 25 and a 7, that other side is going to be 24 feet, right? Yeah. So we've already worked that out. See, that's another thing that gives me hope that this could be a right answer. That this is going to be, if you have 24, well, that's half of 24, so that's the kind of type of number that could work out for us, right? What about you, Kaylee? Do you have this one?
No, sir.
Where did you get lost?
I got all the way to, like, the equation before the answer, but it's sometimes.
Okay, so there might have been in the differentiating or something. That's a miss. What about you, Emma? Did you get this one?
I didn't get that, but I think I messed up
Okay,
the last part, but I can't figure out where I messed up.
all right. Carmen?
Because I got an answer close to that, it just wasn't.
Oh, not exactly that, but close to it. Okay, so there might be some kind of... Anybody get the same answer she got yet? No. Elizabeth, what about you?
I did.
You got the same one she did? Okay, so Emily does a confirmation. Or somebody get a different answer? Well, yeah, I guess I heard you got a different answer, but you didn't know. So let's go ahead and go over this. And see what we get here. So it's a similar type of problem, the one we worked on yesterday. We got a ladder that's perched up against the wall. That ladder is being pulled away at 2 feet per second. So we know, in this case, this one, right? So we have x, so dx dt is going to be equal to 2 feet per second. And then when its base is 7 feet, so now we're looking at this base, 7 feet. And then we know this is 25 feet here. So we have our thing here, F. Well, here we have we want to find this dy dt, right? The ladder's going down. So find dy dt when x is equal to 7 feet. You're given dx dt is
2.
equals 2 feet per second, but that's what it is. And what's our equation going to be? X squared plus y squared equals 25 squared. And so now when we take the first derivative of this, what is that going to be?
2x plus 2y.
2x dx dt
2y.
plus 2y dy dt
Equals 0.
is equal to 0. So is everybody okay up to this point here? All right. And so now at this point, what you can do is you have some options. You can just solve for dy dt first and then plug in numbers. But what I like to do is I like to, as soon as I have the numbers, just start plugging them in. So I know this is 7 feet here. And if this is 7 feet here, what's going to be our y value here? 24 feet. So that's going to be 24. So now we'll just plug in. We'll have 2 times 7. And we'll have dx dt, which we don't know what it is, plus 2 times 24. dy dt, oh actually we know dx dt, that is 2, right? This 2 goes here, right?
Yes.
Yeah, 2, so 2, 2, 2. And so dy dt is what we don't know, is equal to 0. And so we have here is, on the left we have 2 times 7 times 2, so that's going to be 28, plus 48 dy dt equals 0. And if we subtract 28 and divide by 40, dy dt is going to be equal to negative 28 over 48, is that right? Yeah. And then that's going to be simplified to negative 7/12. That's going to be feet per second. All right, dy dt. So what I want you to do is look at the work you've done and just kind of look at where you got stuck, if you got stuck on this.
You can have the same answer because we put the 2 for the dx dt on the y side.
I put the 7 in place of the 24.
Oh, did you? Okay. So just sort of a misallocation of numbers is what that happens a lot. But did you like working out the problem this way? Kind of see where you did to get an answer, and then to see was there anybody who was able to take her answer and sort of work backwards from it?
Can you work it backwards so we can see how you work it backwards?
Yeah, let's talk about that. If you have that, you would have to, what you'd have to do is you'd have to take that and multiply through by that. That'd be sort of hard to do. I mean, the main thing that I saw, when I saw that 12 down here, I said, well, that might be a good number because I knew we were going to have 24 here. And I saw that, so that gave me some hope that we might be on the right track, and that it was a negative number. So I wouldn't really have a really good idea about how to work backwards from this one very much other than that. So that's that one. Okay, let's go ahead and look at the next one here. Again, when it comes to on tests and all this, that latter problem is a very common type of problem. And here, that looks different. Looks like there's a mistake on this one somehow, because I didn't get the same thing here.
You did what I did, switch the 24 and 7.
Okay. Okay, yeah, so it should be 24 and 7 here. Oh yeah. Well, you know what the problem was in this work? There's not a drawing, is there?
No.
So this drawing here straightened all that out, didn't it? When you had that and looked at it more carefully. So this will work. So I don't know I don't know why I left this up here. I might have left this up here as an example of what not to do. I don't know. But in any case,
That's what I did.
Did you? Okay.
The other one?
Oh, this one here? You did this one?
That's the answer I got.
That's what the answer you got?
Uh-huh.
Okay.
Because I put the 24 with
Yeah.
the 2 instead of with the 7.
Yeah. So the 24 is going to be on the Y. So these things would be switched, right? Your 7 is going to be.
Was that you working it out?
Oh yeah, it was, and I don't know what happened. Yeah, this is my writing, and I don't know if I left it up there. I don't know. I can't remember under what circumstances it is, but definitely, I don't see a drawing here.
So
Right.
you're positive the other one's right.
Well, I'm open to suggestion to see if there's something wrong. I don't know. Let's make sure it looks right here. It says the base is 7 feet, so that's going to be 7 feet. That's going to be with the X, right?
Yeah.
And the 24 feet is going to be with the Y, because that's the Y there. And you're trying to find dy dt. So I'm more on the camp that this one right here that Karina did.
How do you know that that's what you're trying to find? Is the dy dt?
It says how fast is the top of the ladder moving down? And the way that this is drawn, now if I wanted to get crazy about it, I could turn the ladder upside down and use different axes. I could use different letters than X and Y, but in the end it's going to amount to the same thing. I like setting it up like this. To me, it's sort of it makes more real world sense to me that I have a floor down here. That makes a good X-axis. A wall makes a good Y-axis. A ladder against the wall. So I like the way. So it just kind of makes more sense like this. But your drawings aren't going to be exactly the same. Okay, find the equation, this one here, find the equation of the normal line to the graph of x squared minus y squared equals 16 at the point 5, comma 3. So what this is not a related rates problem, but it's sort of related to a related rates problem in this. Okay, we find the equation of the normal line to the graph of this at the point 5, comma 3. To find a line, what do we have to have? A what? A point and a slope. We're given a point. And so we're going to have we need to have a slope. And what we have is we take the derivative of both sides of this, and you can do this with respect to y. We want to find the equation of the normal line. So we're going to have we can go ahead and solve this for y, can't we? If we solve this for y, what do we get? I thought we were going to have to implicitly differentiate this, but if we'll try to solve this for y. How do you solve for y here? Yeah, so we subtract x squared, so negative y squared equals 16 minus x squared, then what?
Then can you move the negative to it?
Yeah, so let's go ahead and multiply everything by -1. So we get y squared equals x squared minus 16. Then what?
Then use
Square root. So y equals square root of x squared minus 16. What else do you have to do? What else do you have? Yeah, it's going to be plus or minus. Now in this case we're given a point right here. So if we have the point, we can try these ones and see which one will work. So if we plug in 5, we have 5 squared minus 16, that's 9. Square root of 9 is 3. So is this going to be a plus or a minus here? That'll be plus. So so we just did a little investigation, and so we get a plus. And so what are we going to do next with this thing to find the slope? Yeah, so let's do that. So we have x squared minus 16 to the what power? No. To the 1/2 power, right? So y prime is going to be equal to 1/2, and then we have this x squared minus 16 to what power? Negative 1/2. times 2x. And we know that the 2 over 2 is going to cancel. So what we're going to get is y prime is going to be x over square root of x squared minus 16. So what number do we want to plug in here now? It's going to be either 5 or 3. What do we plug in here? 5. So we get 5 over square root of 5 squared minus 16. So that's going to be 5 over 5 over square root of 9, 5 over 3. So what's our normal line slope going to be? The negative reciprocal. So we're going to get, our equation is going to be y minus 3 equals negative 3/5 x minus 5. So that's going to be our answer for that one. Okay. Let's look at, wait. Let's see what this next one is. I want to just take a look at it. Okay. This next one, we'll probably go over here on this one on. It's Monday, right? Monday. Yeah, this rectangle width problems, this is another category of related rates problems. This is really quite an easy problem, but it's just sort of getting started. But we're going to use the same type of process, which we'll do on Monday, the 10th.